All right, so this is worksheet 3 of the balancing equations packet, and this is where we actually learn how to balance equations. So please fill in the notes as I fill them in. We have already learned that the law of conservation of matter tells us that, we'll see if I have room to write here, we cannot create or destroy, oops, almost fit, matter. Stuff, right? Well, atoms and compounds are matter. So the whole goal of balancing equations is to follow the law of conservation of matter. And so in a really practical sense, what this means for us is we have to get the number of reactants, things to the left of the arrow, to equal the number of products. Right, so if I start off with 3 atoms of oxygen as a reactant, once the chemical equation has occurred, I need to have 3 atoms of oxygen as a product. So a lot of times when you see an equation and you're trying to balance it, I would recommend replacing the little arrow with an equal sign, just to remind yourself that that's the whole goal. I mean, the goal is actually very simple. We want to start off with the same amount that we end with. We're not magicians. We can't create atoms in the process of a chemical reaction, and we can't destroy them either. Now, the details of this get a little bit stickier. So the next thing that you need to know is the difference between a coefficient and a subscript. That's going to be important vocabulary. So this big 2 in this example reaction here, that is a coefficient. They're the big numbers in front of an atom or a compound, right? And this little 2 down here, that's a subscript. Now, for some of you, Chem A was a while ago, but if you think back, you may remember how we figured out to put that little subscript 2 next to the K. It was because we swapped and dropped, right? We said, oh, K has a +1 charge, and S has a -2 charge, and now we're going to swap and drop, so we have to have 2 potassiums combining with every sulfur because we need to have as many positive charges as negative charges. Right? So you have to remember, you don't have to be able to swap and drop still, that was a while ago, but you have to remember that that little 2 subscript, that one right there, that's there for a reason. That cannot change. So that gets to our next bullet point. Very important. To balance, typo, this should say an equation, do not, very important, change the subscript. Sorry, my handwriting's messy. That's subscript. Only add coefficients. You don't get to start putting those little numbers in, okay? When I give you an equation, those formulas have already been properly swapped and dropped. The subscripts stay where they are. The other difference between a coefficient and a subscript. Coefficients affect the whole formula. Subscripts only affect what they are touching. And that may seem not totally clear, so I'll give you a little example here. If we look at this right here, 2SbCl3. The 2 is the coefficient. The 2 affects the Sb. It also affects the Cl. The little 3 only affects the Cl. So what that means is I've got 2 Sb's, that's relatively obvious, right? But to figure out how many Cl's I have, I got to remember that I got a 3 attached to the Cl that's affecting it, but I've also got a 2 in front of that whole formula that's affecting the Cl as well. And so to figure out how many Cl's I have, I actually have to multiply the coefficient by the subscript. 2 times 3, which is going to give me 6. So I actually have 6 chlorines there. All right. Next important point. Polyatomic ions. Remember those? Those were the groups of atoms that stick together, like maybe CO3 or SO4, right? Those are all polyatomic ions, all right? If a polyatomic ion is on both sides of the equation, the left and the right side, then you're going to treat it as a group. Meaning, rather than trying to figure out how many oxygens you have and how many carbons you have, or in the case of the sulfate here, how many S's you have or how many O's you have, it's easier to just ask yourself, how many CO3s do I have on each side? Or how many SO4s do I have? Treat them as a group. Don't break them down into their individual atoms. So for example, in this equation, I have OH on both sides of the equation. So I can treat it as a group. I also have NO3, that was nitrate, on both sides of the equation. So I can treat that as a group. All right, now, when you go to balance an equation, it doesn't really matter where you start balancing, but I often recommend starting where there is a subscript that's telling you there's more than one of something. Oh wow, I just noticed an important typo that I need to fix before I go on. There should have already been a little 2 there. Okay, you don't get to write those in, but I get to fix my typo. Okay, so there should have been a little 2 there. I'm sorry. Okay, so now we're going back to this idea that we start where there's multiples of something. So I could either start right here, because there's 2 of those OHs, or this is how I noticed my typo, I could start right here, because there's 2 of those NO3s. Okay, so I'm just going to decide to start with the OH. All right, just, I don't know, I like it better than NO3. So I notice that I have 2 OHs on the left side of my arrow. And right now, that's not meaning that things are equal, because I only have 1 OH over on the right side of my arrow. So I am going to put a big 2 here. That means I now have 2 of these OHs. That also means that I have 2 of the H's. I affected that single H. So I have 2 H's on my right side. I got to go back over to my left side and look and go, uh-oh, right now I only have 1 H. I solve one problem, I create another. This is going to keep happening when you balance these equations. So I put a big 2 here. Now I've got 2 H's. Well, that 2 affected not only the H, but remember it also affected the NO3. I now have 2 NO3s. So I look over on the right side and look at, there's already 2 NO3s. So I'm good. That's already balanced. I could stick a 1 here if it makes me feel better not to leave that line blank. I don't really have to. Okay, that means I've got 1 Mg. So again, if it makes me feel better not leave it blank, I could put a 1 there. That means I've got 1 Mg. Now those 1 coefficients aren't necessary. If you just left those spaces with the 1s blank, that would be fine also. All right. Next up, the 2-3 rule. I got to give credit to Mrs. Cooper, who I work with a lot in chemistry. She came up with this. So as you practice balancing equations, it's going to start to get easier if you start to notice patterns, which you will just by doing more and more equations. One pattern that Mrs. Cooper noticed is that you very often find you have 2 of something on one side of the equation and 3 of the same thing on the other side. And in this case, you can trust us on this or think mathy and you'll figure out why. You got to get both sides to 6. It's a common multiple thing, and if you don't love math, then just trust us. Okay, so I'm going to give you 2 examples of this. Okay, in this first equation, you'll notice that you have 2 chlorines on the left of the equation and 3 chlorines on the right. That's not equal. That's a problem. So this is our good old 2-3 rule. 2 chlorines on the left, 3 chlorines on the right. I got to get them both to 6. So let's think about how we do this. If I put a 3 here, then that means this 3 and this 2 are both affecting the chlorine, so I'm going to have a total of 6 chlorines there. I got that side to 6. By a similar principle, if I put a 2 here, both the 2 and the 3 affect that chlorine. 2 times 3 is 6. I got 6 chlorines on that side. Now I can't forget to ask myself, what else did I affect? That 2 affected that SB, so now I've got 2 SBs on the right. So I got to put a 2 over here, and I got 2 SBs on the left. Now I'm equal. That kind of 2-3 rule you'll see a lot. Okay, there is one little variation on it that's less common, but it sometimes throws people off, so I got to show you. Okay, in this next example, first of all, I see a polyatomic ion, CO3 here, but when I look over on the right of my arrow, I don't see CO3. It's been broken apart into an oxygen and a carbon dioxide. So I can't try to treat CO3 as a group because that doesn't work very well over on the right side. Okay, so I'm going to kind of erase that. This is a case where you can't treat a polyatomic ion as a group, which is unusual, but if the polyatomic ion breaks apart, it's the truth. Okay, so I also notice that I got 3 oxygens on this side, right? And here I got 1 oxygen and 2 oxygens, right? Now, a lot of times people are going to look at this and they're not going to notice that oxygen. They're just going to see this oxygen. And they're going to think, oh, this is the 2-3 rule, right? Well, careful. Look at this. I got 3 oxygens here, and here I got 1 plus 2. So 1 oxygen plus 2 oxygens gives me 3 oxygens. I've already got 3 oxygens on both sides. That's already equal. And I can check my magnesiums and go, ooh, look, those are also equal, 1 of each. So this is a case not of the 2-3 rule, but where I've already got a balanced equation. I could just leave this blank and it would be right. Or if it makes me feel better, I can put 1s in here. So keep in mind that sometimes when you balance equations, you don't need to do anything. They just already work out balanced. That's kind of like, I feel like it's your lucky day when you find that. Okay? All right, my last couple words of wisdom. Approach these problems like a puzzle. Use a pencil and do not be afraid to erase. As you practice more, you'll erase less, but at first you're going to erase a lot. Each time you add a coefficient to balance one part of the equation, ask yourself, what else did I just affect? Right? If we put a coefficient, a 2, in front of SbCl3 to try to take care of the Cl's, well, I also just affected the Sb. Right? That was what happened up here. Right? So you got to look at the whole problem. Last but not least, learning to balance equations takes time and patience. We're going to offer you lots of practice. So long as you keep practicing and fixing your mistakes and having us check your work, you will get better. Please trust that. But it's going to take a little while, and you need to trust the process. Okay, so the next time I see you in class, we will begin to practice, and I think over time you will see that you learn.